My name is Kumo, and I am a course advisor for ECT. Welcome to today's webinar that's going to be presented by Dr. Shalon, who's our lecturer for the Industrial Automation course. And in order for us to just minimize all the interruptions that may occur, could you kindly just switch off your notifications? And we also do have a Q&A function. This is so you can put your questions in, and then Dr. Shalon or myself will take them closer to the end of the webinar. But if you don't have that option, then please feel free to use the chat box. And for today's webinar as well, there will be a certificate of attendance, which will be sent to you within 4 business days after you've completed the survey. And then there's also a copy of the recordings and the slides that will be sent to you. And that will be sent to you within 2 business days from today's webinar. And can I just stress that you need to complete the survey within 2 business days. And then after that, the link will expire. And that's just to ensure that we get the certificate of attendance and the recordings to the right people. And just to give you a little bit of information about ECT and what we're about. So ECT is an engineering specialist institution providing and offering industry-driven programs with world-class accredited education. And that's all made possible by our lectures and instructors and our unique delivery model. And for today's event conduct, just to listen to my instructions so we can have a smooth webinar, so to speak. And lastly, today's webinar is advanced maintenance practices of complex manufacturing assets, which is presented by Dr. Shalon. You can take it away, Dr. Shalon. Thank you so much.
Thank you, Como, and thank you for the introduction. So hello, everyone. Welcome to this webinar. Thank you for attending this webinar and being interested in knowing more about maintenance and maintenance practices. So to give you a little bit about myself, my name is Dr. Abdul Shalan. I am the program leader for undergraduate and postgraduate industrial automation programs at ECT. My background is mechatronics engineering and a master's in engineering management and a PhD in advanced maintenance practices and automation systems. Everything is showing how it should. I think so.
Yeah, everything on my side is fine.
Okay. So, as I was saying, these are my background. I did hold the post of lecturer at Sunderland University before I joined the ACT and then joined the ACT as a program leader. Did hold many different posts related to industry and research. Supervised many students, whether they are undergraduate, postgraduate, or PhD students. Did carry multiple consultancy projects and industry-related and government-funded projects over the years to create quite a strong link and understanding between academia and industry. Without further ado, we are going to talk about maintenance today. So for today's agenda, we are going to talk about maintenance spending, the trends in maintenance, what are the modern maintenance practices, and we are going to focus on subsea cables manufacturing and the change in awareness, attitude and skills, different incidents related to maintenance, the different maintenance strategies, and what happened when we neglect maintenance, and what is the next big thing. So to start with, in order to know what really maintenance is about and why is it important in general, we have to have a look at the spending, because everything in life is about money and about how much does it cost. So you will find from the research that in Europe itself, we have 300 billion annual spend on maintenance, and it employs 3 million people. In the UK by itself or alone, we have 22 billion annual spend on maintenance. When you think about maintenance, think about any factory, or if you're an engineer and graduated, majority of the jobs that you will find at companies, they are mainly maintenance related. So you are an engineer, whether you are electrical, mechanical, control, whatever the area that you are working at. You can work in different departments, whether it is projects, installations, etc. But you still find a big portion of engineers working as maintenance engineers. So the whole idea is, well, a company buys a machine or sets of machines, and they want to keep them working. Just like having a car, and you want to keep that car working. You don't want it to fail, you don't want it to break down, because if it did break down, it is going to cost you a lot. And in an era where everything is fast-paced, every minute is counted and costs a lot, it is really a big thing to avoid having your machines stopping and not producing anything. But in the same time, while the machines are broken down, you are still spending money, you're still paying wages, you're still paying bills, you're still having all the different commitments. Different aspects impacts breakdowns and impacts downtime in general. So if we started to look into the oil and gas industry, for example, start to think about the drilling machine, or any of the wells. If any of these different systems stopped, you start to think about, well, that's millions of pounds worth of loss in downtime, because it's not just the machine stopping, it is the whole system and the whole revenue is stopping. So maintenance is a very important aspect, and depending on the industry you're at or you're thinking of, it might be very important or might have less importance, but in general, it is a very important element. Think about the nuclear industry, for example, and the nuclear sites for energy generations. Well, you can't really have anything going wrong at such a site. Everything has to work. You can't really afford for anything of the reactor or whatever it is to stop or to have an issue, because this is going to be a catastrophic issue, and it is going to cost a lot and impact the health and safety and the well-being of people around it. And we have seen this with Chernobyl, for example, and many other cases that you might think of. The same thing can be applied to many different industries, and you start to think about, well, because of bad maintenance, the whole industry or a whole company or the whole sector can collapse on itself. So when we look at maintenance in general, we start to look into what are the different trends that we have within industry. So within industry, we have certain trends related to assets. So we started to think about, well, in the past, there wasn't really much of demand, or or companies were not really focused on reaching regional markets. You didn't have much of a competition. So there was not that much of a need for the assets to be working 24/7 and to have or to use every single minute available in order to produce and make parts or products or whatever. So new trends with the incrementing competition, with the open markets and reachability to different markets, we started to see the trends of the need for the assets to run longer. So it's not just only one shift from 9 to 5, so it started to be 2 shifts, started to be 3 shifts, 24 hours running of these machines. We started to have or to see the impact of assets failures can be very large. We started to see complex in assets that if anything stopped or went wrong, because it's a system, it's a big machine, everything is depending on each other, you start to have bigger issues and more costly issues. When we look at the expertise, we started to look at the downsizing, and the aging workforce has caused skill gaps at the plant sites. And this is very common in Europe, like how it is in Germany. There is a big issue with the workforce, and the same thing with the UK. You start to see, and I have seen that many times, that companies are actually shutting down because they can't find people to work. They can't find people to run the machines and to run the production lines. So they start to move somewhere else. And if they wanted to have or find someone local, that person knows that, well, there is not much or there is not many of me, so they're going to charge a lot in order to work at this company, which basically eats in the revenue of the company. And again, it forces the company to move abroad. And this is one of the reasons lots of the different companies, or I think all of the companies, move to China and the Far East in general because of the workforce. We started to look into the technology, and the technology is evolving. When you see a product that is getting more complicated and more fancy and better and looks more advanced, that's because the machines that are making that product as well got more advanced. You can't really make that much of a complex advanced products with simple machineries. Things evolve and things develop. So with the complexity that you can see with your mobile phone, for example, and the development from 20 years ago, the Nokia old phones, to what you have with the iPhones and all the smartphones, the same development happened in the machineries that makes them, because you can't still make iPhones with the same machine that used to make the old Nokias. So machines got more complicated and more complex and started to have all of these different fine manufacturing elements in it to make or to manufacture the product that you are holding. We started to look into working practices and started to look into how maintenance started to move away from being reactive, which means that I'm only going to fix it when it fails, into being proactive. Proactive meaning that I want to avoid the machines from breaking down. I don't want it to break down, so what should I do? Think about as well your car, and this is an example that you are going to hear a lot in this webinar, that, well, cars, well, if you didn't take it to maintenance or service every year or every whatever the period that you are taking, you might start to have issues and the car might start to break down. And all of these different things started to appear in the manufacturing sector as well. So looking into the modern maintenance practices, and we started to see rapid changes over the past 20 years. As I said, with the last 20 years, things developed dramatically in every aspect of products and manufacturing that you can see. You started to see from 20 years ago until now, everything changed in a very big way. And as I said, when you see a product changing that much, that's because as well, the machines that makes it developed that much as well. So we started to see much more complexities in the machineries. Machines are not as simple as they were before. We started to see these machines are very valuable and costs a lot, like how you would hear, and we all heard about the semiconductor machineries and the lithography machines that makes the semiconductors, and it costs what, 450 million. That's a single system. That's a single machine that costs that much, and it is that much complex that takes month and month in order to just commission it and to adjust it and make it work how it should. So things became much more complex, and we started to look into, well, with that complexity, we need to start to look into how can we maintain and keep these machines running with the highest quality as much as possible, with the development with new maintenance methods and strategies. And we started to see changes in the views of how companies are viewing these strategies and having or viewing the maintenance in general. In the past, or generally, you start to look into how management and the owners of the companies, they always look at maintenance as a waste because what they think and understand is that, well, I want to spend money, but I want something in return. And generally what they do, well, I'm spending money on raw materials, I'm spending money on people that work and transform that raw material from a state to another, from a piece of wood to a table, from plastic to monitors and keyboards and whatever the products are. But maintenance, I'm just spending money and money on maintenance, but it's not making anything. And they don't really get the idea that, well, you are spending money now and you can't really see a direct impact or a direct reflection of your spend, rather than you can see it over time with the machines running how they should. You don't have that much of a bad or reject products or low quality products. You don't have lots of downtime. You have all of these good things and the machine starts still working how it should. And this is the change in awareness and views that peoples and companies started to have towards maintenance. I have an example for you today, and this is a company that I did work with, and this is a machine that I did work on, and this is a subsea cables manufacturing machinery. It's called the VAM, and the VAM stands for Vertical Helix Assembly Machine. So when you think about the subsea cables, you start to think about what is actually moving the cable, moving the power, moving the gas, moving the internet and the fiber. What is moving all of these different things between continents and between countries across the oceans? And that is the subsea cables. We all heard about the subsea cables. We all know about subsea cables because of the recent incidents that happened and still happening all the time. And now we started to realize, well, this is a very important thing. So when you think about a subsea cable, you start to think about this is a bundle of different cables. So it is a bundle, and this bundle has many different setups. And these different setups depends on the need of the customers and what they want to transfer. Some would want energy cables, some would want fiber and internet cables, some would want gas cables, some would want whatever. So these different bundles with different criteria, they get made and put together, and they are laid on the surface of the ocean. So this bundle has to be made very accurately with the top quality, basically, because it's not going to be easy to fix it if something wrong happened to it at the bottom of the ocean. It's not that easy to go down and fix it and to do all the repairs. It costs a lot. So in order to make it, it had to be made to the highest spec, to the highest quality, and to be made perfectly. Another thing you start to think about, these are miles and miles or hundreds of miles long of cables. You don't really need, or you can't really afford to have cuts and connections between all of them. These are weak points. So in order to have all of this, you need a machine that works perfectly for days and sometimes weeks nonstop, because you are making this miles long of cables, and you need to have all of this working how it should all the time for weeks long. So this is how this machine works and operates. So what you can see around, you can see the carousel. I'm just going to lower the volume. These circle carousels, these are the carousels that holds the different single cables or pipes that needs to be included in that bundle. And all of them gets extracted and entered to the middle or to the center of this machinery. And they are all grouped together, and they started to be pulled from the middle to the top of the machinery. And different stages that you have in this machine. So this machine is considered the largest machine in the world because how big it is. It is 52 meters high machine. And these bundles or carousels, these are the carousels that sometimes you would see at the side of the roads, like a house story big. So these are massive carousels. So you start to think about, well, I need to have the feed for each of these cable with a certain amount. It's not just a free rolling cable, rather than it is a controlled feed mechanism. And that controlled feed has to be very accurate and very specific to each cable or each pipe that it is included. So in order to feed in a power cable is different from feeding in a fiber cable. Each has different elasticity and different extraction process and force. So everything has to work how it should. And the pulling mechanism of the whole bundle from the top and the center of the machinery, again, this has to be measured and has to be very accurate. You don't want that bundle to be crimped, and you don't want it to be stretched. So everything has to be very accurate and very detailed. And that's why you can see, well, they are rotating with a certain amount, and at the same time, they are feeding these different cables again with a certain amount and a different or a specific pace. And all of this has to work, and this machine has to work. The whole system is rotating on a plate. So this machine has to work sometimes for weeks in order to create that specific bundle or that specific order of cables. And if anything wrong happened in between, they will have to scrap the whole thing and restart again. That's a waste and loss of product. That is a waste of time, and customers are waiting for their products, and different cost and reputation impact on the company itself. A different variant of this machine is the horizontal type of it. So this is a horizontal helix machinery. So you can see these yellow different carousels. These are the feeding carousels for all of these, again, different cables and different types that needs to be included. And here it is getting all pulled into one specific bundle that gets coated and gets tested, and all of these different processes that we're not going to get into it. But it's just to show you how important keeping everything working how it should is important. You can't really make a bad product because it's not going to be easy to fix it in the bottom of the ocean. So everything has to be very critical and has to be very good in how it is working and operating. With this, we started to see changing in awareness. So we started to look into how the growing awareness of how equipment failure affects safety and environment. We started to look into and find out that when the machine is not working how it should, it can be a safety hazard. It can emit harmful gases. It might have something that breaks down and injure the person that is operating the machinery. And all of these are things that started to impact the surrounding environment and the people that are operating. So that is a change in awareness. Another thing is the awareness of connection between maintenance and products quality. We start to realize that, well, if the products are bad, that's because the machine is not maintained well. It's like your car. If your car is shaking and making all the weird noises and sounds, that is because you are not maintaining your car well. It's not because the car is bad, it's because you are not taking care of that car. We started to look into having a pressure to achieve increased level of equipment availability and maintain lower costs. As I said, we started to have the need for these machines to be running for hours, days, weeks, non-stop, and without any breakdowns, without stopping, because we have all of these orders to fulfill, or we have an order or a product that needs that much time for just one item to be produced. And in the same time, we don't want to spend a lot because, well, if we did start to spend a lot, our product's cost is going to increase, which is going to make our products not appealing to the customers, and the customers are going to start to go to different vendors. So it is a competition in the market element as well that companies started to realize and to know that they need to do it in a better way. Looking into the attitudes and skills, we started to have a feel that maintenance staff need to adapt new ways of thinking. It's not all about working hard and doing as much as you can, rather than working smart and knowing what exactly needs to be done and doing it when it needs to be done. I did work with different companies in the past, and you start to see people that are working very hard and having that big maintenance slog that they are going through. And that's not the best practice. This is not how things should be done. In return, it is all about what is important and what should I do? What is the essential things that if I did, they are going to prevent products degradation in quality, or they are going to reduce machine stopping and breakdowns, or minor or major failures, and how can I do this? Remember, when you are doing maintenance of your machineries, this is a machine that it is not producing. So still, it is considered a downtime or out of operations time. So how can I avoid this? For example, like how how I'm doing now. My car is at the garage getting fixed, and we have MOT, etc., that needs to be done. So it is there for a couple of days now. I can't use it. So now I can't really go to do my chores. So these are the things that needs to be thought of. We started to see that managers are seeking new approach to maintenance. And we are going to talk about these new approaches in a second. We started to look into operators' involvement. Operators' involvement, it's all about, well, I have uh, I have a machine, and this machine has different aspects and different parts to be checked and to make sure that they are working how they should. But do all these checks needs an experienced maintenance engineer to carry them out or not? And this is when we started to look into, well, I can train my operators to carry out simple maintenance tasks. These simple tasks can be as basic as cleaning, making sure that everything on the gauges before they start the operation is reading certain parameters. You don't have any errors, you don't have any issues. It is like you are driving your car, you're not a mechanic, but if you started to see different lights on your dash or something that is going wrong, so this is the time that you might want to take it to the garage, or you might, for example, if you have a low water in your wipers. So this is something that doesn't really need a mechanic, rather than, well, you have a low water level in the wipers, so top it up. Just get some water, top it up. So this is some sort of basic maintenance you as an operator you can do. It doesn't need an experienced person to go to the garage to fill in the wipers fluid for you, rather than this is something that you can do. Same thing for the tires pressure. If the tire pressure went down a little bit for whatever the reason, you can do it yourself. You don't need to go to the garage to do it, or to go to the tire shop to do it. You can just do it at the gas station, just top up your air. And if the issue persisted, so you can start to go to the tire shop and find out what is happening. But the whole idea is you start to look into how can I get the operators involved into carrying out simple tasks. And that's the whole idea of the new approaches and the new things that started to emerge. Looking into different maintenance related incidents, and as I told you before, this is one of the things that maintenance did impact industries very much, that they got out or eliminated a whole industry or a whole product. And this is one of the things like we can see with the Concorde, for example. So Concorde, the supersonic aircraft, that was something that is amazing, out of a movie at the time. So you can go between the US and Europe in, I don't know, a couple of hours instead of 10, 13 hours, whatever it is. I'm just making numbers. But because of poor maintenance and the poor attention to details, started to have all of these incidents and all the issues and all of these crashes that actually killed people. And because of this, the whole Concorde projects got eliminated and got out of the service. Well, we can't have this. In the modern time, maybe you heard about this with the Boeing 737 MAX thing, where it had a couple of crashes. Uh, Many people died, and that's because of how it was made and how it was maintained, etc., whatever it is. But you start to look into, well, if things are not made properly and maintained how they should, issues happen. And these issues can be fatal. And because of that, big impacts can happen to that industry, and lots of different losses, whether it is related to how it is with the Concorde, the whole thing will disappear, or the company will lose billions of dollars, pounds, in order to recover from these issues. Another thing, we had the Hatfield rail crash, where it killed 4 people. And that's because of cracked rails, because it was not inspected properly and it wasn't cared of how it should. And many other incidents you can look into. You can start to think about, well, maintenance is very important, and it can be really fatal. So, basic example with car maintenance, what must be done to maintain your car? For example, you have to change the oil every 6,000 miles. You have to check and change the air filter, check or change the hoses, belts, connections, rotate the tires every 12,000 miles, make sure they are in a good condition. clean inside and wash outside. This is going to be actually a good way. You might think that, well, why washing a car and cleaning it is important. It's not just to look nice, rather than, well, when you are cleaning around your car, you start to see issues if they are hidden below the dirt and the rubbish. And that's the same thing with manufacturing assets. If you have a machine and machines, for example, hydraulic press. So this is a machine that is using oil in order to carry out its operation. If you are cleaning around your machine on a regular basis, you start to notice if you have an oil leak because, well, I started to see a patch of oil. It's appearing in here. I did clean today. Tomorrow, I'm having, or I can see a little bit of oil as well. Where is that coming from? You start to realize that you have a certain leak, a small leak that's not appearing on the system or it's not noticeable, the machine is still working, but you start to see that a developing error or an issue or a failure is happening. Replacing your brake pads, regular inspections, all of these are different examples of maintenance and how different maintenance activities can be carried out, whether it is basic or complex. It can vary and it ranges between the spectrum or over the spectrum. What can be the implications of poor car maintenance? So you can have premature failures, so things that can fail much earlier than when they should. If you did not rotate your tires or balance your wheels or do the wheel balance or what is it called? Forgot or the tires tracking, for example. If you didn't do your tire trackings correctly or you didn't do it every year, for example, a couple of years, it is going to impact your tires. So instead of your tires lasting for 10,000 miles, they're just going to last for 2 or 3,000 miles. So this is a big impact. If you are not changing the oil regularly, how you should, well, your engine lifetime is going to decrease. So instead of lasting for 200,000 miles, it's only going to last for 100,000 miles. We give the examples of cars and the simple things about cars. You might think this is simple, this is easy, but in manufacturing assets, these little things are magnified. So this is a bigger thing if it is related to the oil and the motor of that machinery. Think about the oil tankers in the ocean. So the whole engine of this oil tanker as the size of a big hangar. So if that oil or that engine is not getting maintained properly and changing the oil frequently and taking care of it, that engine costs millions. It's not just little thing or in hundreds or thousands to fix, rather than it is in millions. So you start to see premature failures, you start to see increased running costs. Your car starts to eat more gas and consume more gas in order to take you around. So instead of consuming 50 miles per gallon, now it is instead of doing 50 miles per gallon, it is doing 20 or 30 miles per gallon. So much higher consumption. Same thing about machineries at factories. They start to consume more and more energy. Unexpected breakdowns, so they will break down at any different points. Poor operators' morale, so the people that are using the machine are not using it how they should. Think about when you're driving a car or when you're riding a taxi. So you might get with a driver that is not really respecting the car, going fast over speed bumps and driving harshly this car, not really taking care of it. This is the bad or the poor morale of the people. They don't care. They're just doing it and driving or whatever, using the machine how it should, not using it how they should, and that decreases and impacts the remaining lifetime of it. You start to see that you might have personal injuries or death with whatever the failure that might happen. Might have a tire flying off your car and then just have an accident, or the brakes failure or the brakes fail, and eventually you have a fatal or life-changing injuries that are happening. So what are the maintenance strategies? So going back in time, what started with when you started to have manufacturing in general and manufacturing and industrial revolutions, first thing that has been used was run to fail. So I don't have really a strategy or a way of maintaining the machines rather than, well, I'm using it. If it stopped, I fix it. At the time, it was okay. Machines were simple. The demand was not that high. So things were very much flexible. I didn't really need a strategy or a specific way or a study in order to fix these machines or to have that much attention to maintenance. And then things developed and started to have production lines and started to have reachability, a customer base, competition in the market, etc. All of this started to create the need for something better than just waiting for the machines to fail. And this is what we have with our cars, really. So we have time-based maintenance. So the time-based maintenance is that, well, I have a list of different tasks that I can do or I should be doing every day, every week, every month, every quarter, every 6 months, annually, or based on running hours. So after 1,000 running hours, I should be doing this. After 10,000, I should be doing Y. After 100,000, I should be doing Z. List of different tasks that I can be or it can be done over time. It has its issues because, again, it is preventing a lot of different issues from taking place. But think about it in the way that, well, if you have a car and I have a car, I drive my car a lot, you don't. My driving habits are bad, your driving habits are good. So my car does not really, or your car does not really need that maintenance that we both have the same car, we both have the same schedule. But your car, because you're not driving that much, so instead of doing annual maintenance, this can be stretched into 2 years or maybe 18 months. So you have some room to extend the lifetime, or you have already extension of the lifetime of these parts that you are going to change. Think about, for example, the people that have supercars or whatever, the sporty cars. They don't drive them that much, really, maybe the whole thing a month over the whole year. But every year they go and they change the oil and they might change the tires and change the belts, etc. So all of this is just a waste because, well, instead of just changing the oil every year, you could have did it every 2 years. These belts, instead of just changing them every couple of years, they could have lasted 3 years. But for me, because I drive all the time, maybe I'm a taxi driver, I'm driving all the time, I'm consuming a lot of the car's lifetime. So instead of doing it every year, I might actually need to do it every 6 months because, well, I am already driving it a lot and my driving is bad or the conditions that I'm driving at are bad. And this is happening, for example, well, I'm from Egypt and in Egypt, well, it is hot. We have a lot because it is deserty country. So we have a lot of sand, basically, everywhere. And I think if any of you are from Africa, so you would know what I'm talking about. So cars, if it is like a Mercedes or BMWs, they have to be maintained much more frequent than what the company is saying. You need to go and check the filters and change different things in order to keep the car healthy. So this is the time-based. So it has its good elements, but again, it has lots of different bad elements. And then we have the condition-based, which is basically using sensors to tell us the different conditions of the components of these machineries, like how you can have a sensor for your oil level, you can have a sensor for the temperature, you can have a sensor for the tire pressure at your cars. Same thing is happening at the machineries. You can have vibration sensors on the motors, you can have pressure sensors for in the lines, if it is a pneumatic line, hydraulic lines, you can have many different things. So condition-based is much more of having an insight and actually knowing the condition of the different components of your system. So these are approaches. And then we started to have strategies. So a strategy is a framework, and that framework is a collective of different tasks and different elements that are coming together in order to make the machines running how they should. So over the time, we started to have three different strategies. We have RCM, TPM, and CPM. Each of them was developed whether it is in the U.S. Army, or it was developed in the Navy, or developed in the aviation industry, each with a different focus. So in the aviation industry, you can't really have any failure that are happening to the aircraft, because if anything failed, well, everyone is going to die, basically. So RCM in general, this was developed to be a machine-focused strategy. So it only focuses on the machine. It makes sure that everything about the machine was looked into, was studied in details, and looked into in a very detailed level to make sure that, well, I know everything about this machine. How could it fail? RCM has its own, we're not going to get into it, it's a big story, but it has its own questions, it has its own risk priority numbers, FMEA element, etc. I'm not going to get into this, but it is a machine-focused strategy. Make sure that this machine is going to keep running. And when we look at the TPM is a whole organizational strategy. So it focuses on everything within the factory. So it focuses on the machine, it focuses on the people, it focuses on the surrounding environment of this machine, it focuses on everything that is within that company as a collective of different things, that when you do them all, you increase the overall efficiency of that company. And then the condition-based maintenance, which is very much the condition-based approach, but it has different types, different ways, whether it is wired, wireless, the communication between machineries, between system protocols, etc. So to simplify things, it is just relying on the use of sensors in order to give us an insight into the conditions of the machineries. So these are the strategies, and moving on, what is the barriers to these strategies? What prevents companies from applying all of this? So first of all, limited staff. We don't have the people to do it. Usually companies will have an engineer or one or two maintenance engineer maximum, if it's a small or medium company, that are taking care of the maintenance, because they don't really want to spend much on maintenance. We have lack of training. Again, not much getting spent on training. Inadequate diagnostic equipments, the machineries and the tools that are getting used to carry out the maintenance tasks are basic, simple, outdated. Missing technical documentation, which is very common, that, well, I can't really find the manual of this machinery, so I'm just going to improvise and do things by heart or based on experience. Budget issues, typical barrier, we don't have the money to do it. Inadequate monitoring of equipment, so you don't have the tools and the correct tools to monitor, or the knowledge to monitor the equipment properly. Lack of management commitment, management always looking into production and making parts, products, etc. Don't really care about maintenance. And the poor morale of the people. People don't really feel that they belong to this company or they care about this. They just go from 9 to 5 to do their job, and that's it. So when we look at the neglected maintenance, so what happens? Why it happens? So operating equipment and manual override. So the machine is having an issue, but I'm still going to work it and I'm still going to use it and produce parts or doing whatever it need to be doing. I don't care. I'm not just going to stop and take care of it, inspect it, fix it. I'm just going to push the machine beyond its capabilities. Incorrectly adjusted equipment, and that's because of, well, you don't know really. If you don't know, you don't know. So you don't know how the machine should be prepared, adjusted. You went to a bad mechanic for your car. They don't really know how to fix it. They did fix it badly, basically. So they didn't adjust things how they should. So the car, after a week or two, failed again. Inefficient operations. So the operations itself are not adequate. The environment and the materials used are not how they should. Inoperative equipment. So the machines are not going to be working how they should. Different leaks that can happen because of steam, air, oil, water, material, whatever it is. Just you have different leaks, cuts in the systems, breaks in the system. Faulty control systems, you're not taking care, you're not caring about your control system that operates the whole thing. It is dirty, it's messy, it has different issues that are not getting focused on. and you have an increased costs that are results of all of this taking place. So the whole, eventually that product's costs is enormous. And as well, you have safety issues. And on the other side, when you are having good maintenance, what you get improved equipment efficiency. The machines working properly, they are available, they're making good parts. You have increased product quality, you identify equipment defects easily, you have reduced equipment failures, they're not breaking down all the time, you have increased production, you have improved safety, you have minimized damage to the equipment, you provide guidelines for new equipment purchases, so you know, well, I'm using this well, I've been maintaining it properly, now I know what is good about it, what is bad, and this guides me into the future purchases. Uh, Effectively prioritizing decreasing resources, so you know where to spend what you have and where to direct your resources. You have improved staff morale, they are working, they know that you're not just telling them to just work and push the machines beyond its capabilities, rather than, well, they know that you are caring about them, so the morale increases over time. You have amazing reduction in energy consumption, up to 28 increase on year or year on year. Um, you develop an energy management culture, so the people know what would be the impact of a good maintenance and what would be the good practices of reducing the consumption of energy. And because of this, you start to have overall reduction on your running costs. So what is going to be the next big bang, or what is the next thing in maintenance? We started to see AI that is emerging rapidly over the last 3 years. So it's everywhere now, and it is all about helping maintenance or helping adjusting maintenance plans and having better insights into our machineries, better insights into the data that we are reading and collecting to tell us what can go wrong in the future. So AI is emerging very rapidly in maintenance, in diagnostic of the machineries and guiding maintenance tasks into carrying out tasks. We have augmented reality, so the AR for guidance of the maintenance staff into carrying out the different tasks. We have new technologies related to the control systems, related to the actuators, related to many different aspects of the machineries that are emerging. And at the same time, it is happening in maintenance. So better sensors, smart sensors. We have better ways of data collection and analysis and the IoT that we can hear and seen over the past 10 years. So it is emerging that, well, it's not just machine-based locally that we are collecting data from, rather than data can be translated, can be sent over the internet to different places for data analysis and monitoring. So all of these are new emerging technologies and big things that are happening in the industries that are guiding us through. So at the end of the day, maintenance is essential. Depending on the industry, depending on what you are making, and depending on the quality that you are seeking and the cost implications that you might be suffering from or coming across, start to think about the importance of maintenance. As I showed you different examples about sectors that vanished because of poor maintenance, or the impacts on the fatal impact on people's and the well-being of people that can happen because of poor maintenance. So keep that in mind, that you might be going into your degree, or you're coming up to, you are an engineer and doing a master or just improving your knowledge. You might be a maintenance engineer. You might be the person that is taking care of these different systems. Even if you are updating the systems and changing things within the machineries, if you are operations, you have still that part of your life that is, or your day-to-day job that is maintenance related. So always look into how can you do it effectively, how can you do it better. Don't listen to the older generations, because older generations only know older knowledge and they are doing things in an old way. Look into the new trends, look into the better way of doing things. How can you manage your work in a better way? How can you fix the machines better? How can you keep everything efficient with the lowest cost implications and the highest uptime possible of your machineries, whether through using CMMS, computerized maintenance management softwares to organize your workloads, using sensors, using AI or whatever machine learning for data analysis and trends analysis to find out when could it fail. So instead of just doing it rapidly, like time-based, well, when is better to do it? All of these, look into training, look into different things. I would suggest to, if this topic got your interest, look into TPM, look into the RCM, look into how they're getting applied and what are the implications of them, and how can this suit your operations and the way that you are doing things. It might be an eye-opening, it might be something that, well, I should have been doing this. It is all simple things. It's not something complicated. It is complicated when you start to get into the technology and things, but concepts-wise, it is simple concepts that you can start to build on top of them and make things work how they should. So this is going to be it for today. I hope that was useful, was beneficial, gave you a little bit of insights into how the industry works, into how things can be done in a better way. And good luck with your careers, with whatever you're doing. Please ask if you have any questions before we wrap up. We have 9 minutes, 8 minutes left. So if you have any questions, please ask. I'll hand it
Thank you so
over to
much.
you, Tomo. Thank you.
Thank you so much, Dr. Shalan. Always very informative. And thank you to all our attendees for joining us today. Hope you learned something and hopefully this was worth your time. So I just want to let you know and inform you about the certificate of attendance for those who have not yet heard about them. So I will be including the link, which I now have on the chat box. That's the link you can use to um, basically fill out your information so we can get the certificate of attendance, the recording, and the slides to your email. If it's not in your inbox, then it will be in your spam mail or junk mail. So please check that. And that's the QR code, so you can scan that or use the link that I have included in the chat. So ECT is currently running a promotion for the professional certificates of competency, and these are our 3-month short courses. Normally they're around £933, so there is a discount promotion running, and I have included the information in the chat box, so you can just take a look at that and see what might interest you there. So in terms of our higher education courses for September, we've got our bachelor in electrical engineering and the one in industrial automation. Those are both starting in September. If that doesn't work for you, then February next year is our next intake date. And then with our masters, we've got a master in power system analysis and renewable integration. And the other one is in industrial automation and instrumentation control. So those are starting this year in October, but if that doesn't work for you, then February next year is also an intake. So you can take a look at that. And lastly, I would just like to give you some information with regards to our next events. So these are like our webinars that are coming up. I have included the link in the chat box as well, so you can register for those and see which one will interest you and join us for those ones as well. Um, I don't see any questions. So if there aren't any questions, we can call it a day. And once again, thank you for attending. And Dr. Shalon, thank you for your time and providing us with all this knowledge.
Thank you, Como. Okay, see you guys later.
Okay, bye.
Bye. Bye.